is Gaussian on this side. So today and we are dealing with the Ramachandran plot. So let's get started. So basically Ramachandran plot is also known as Ramachandran diagram or phi and psi plot. Phi and psi plot. This is phi and this is psi. Deal with. Now here basically Ramachandran plot is the way by which we could identify the secondary structure of the protein depending upon the rotation or the degree of freedom of the dihedral angles. So basically what are the dihedral angles? So here this one and this one are called as dihedral or the torsion angles. Dihedral or the torsional angles. And they are called as a phi. This one is the phi and this one is the psi. This one is the phi and this one is the psi. Deal with. Now here if I will be going for the other bonds are also there and maybe they will be showing the torsion up to some extent. So basically in this case this bond, this one, in this bond the bond between the carbonyl carbon, this is our carbonyl carbon, the bond between the carbonyl carbon and the nitrogen has partial double bond, has a partial double bond. How come? Here basically here if you are observing here we are having oxygen. And we do know that the oxygen is the most electronegative element. So basically this oxygen will be having the negative charge from the carbon and making the carbon as a positively charged ion. Okay. And if you are observing here that the nitrogen is having no lone pair of electrons. And if these lone pair of electrons are there on the nitrogen, here it will be literally forming a partial double bond. Here it will be literally forming a partial double bond, and whenever the double bond is formed, this rotation will be restricted. This rotation will be restricted. So basically only the rotation will be allowed into either NC alpha or the CC alpha. Here I am reading in this direction NC alpha and in this direction it will be CC alpha. Deal with the case. So basically whenever I am dealing with the NC alpha, I will be calling the bond angle as phi. And whenever I am dealing with the CC alpha, I will be calling it as psi. Deal with. So basically here the secondary structure of the protein could be the alpha helix or the beta pleated. It could be the alpha helix or the beta pleated. And one more case, if you are computing the Ramachandran plot, the atoms are treated as hard spheres. They are treated as hard spheres. Deal with the case where the dimension will be corresponding to the van der Waals radii or the van der Waals interaction. So basically whatever the angle that is resulting into the collision of the sphere which is regarded as hysterically unfavorable. And basically here we will be having different regions as well, in which some of them will be allowing the conformation and some of them will be not allowing the conformation. So let's get started. Here the Ramachandran plot is. If you are observing the case, please do remember one thing, that there are there are three regions basic. The first one is called as a white region, the second one is called as the red region, and the third is called as the yellow region. So if you are observing the white region, do remember one thing, that the white region is disallowed for the amino acid. The white region is disallowed for the amino acids. If I am giving the numbers, this will be the quadrant number 1, this will be quadrant number 2, this will be quadrant number 3, and this will be none other than quadrant number 4. Deal with. Okay. Now, so the fourth region is called as a white region, which is disallowed for the amino acid, except one called as, I am writing the name called as glycine. Except glycine, all other amino acids are prohibited here. Okay, deal with. Now, dealing with the most allowed one, that is called as red region. That is called as red region. So if I am drawing here, this one and this one are most allowed. This one and this one will be most allowed one. Okay, deal with. Now these are the most allowed one and they are having beta sheets, or specifically if I will be going for, they are having this one is having parallel beta sheet, this one is having parallel beta sheet, and this yellow one is having anti-parallel beta sheet. Anti-parallel beta sheet. Deal with. I will be dealing with the alpha helix and the beta sheet as well. So here if I am dealing with the second quadrant, that the second quadrant is only having the left-handed alpha helix. It is only having the left-handed alpha helical structures, whereas the third quadrant is having right-handed alpha helix. It is having right-handed alpha helix along with parallel beta sheet. Along with parallel beta sheet. And this yellow portion is called as anti-parallel beta sheet. Anti-parallel beta sheet. And if you are dealing with this case, here you are having here in this case you are having the psi angle, whereas here in this case you are having the phi angle. That is plus 180 and this will be minus 180. And in the same case here in the phi angle as well. So deal with all of them, the phi and the psi both. You can observe now. The psi angle is in the y-axis, whereas the phi angle is in the x-axis, or what we call is in the ordinate and the abscissa respectively. So deal with those cases as well. Okay. So now we have to know about what is the meaning of the alpha helix, or what is the meaning of beta pleated structure. So basically, if I am dealing with the alpha helix or the beta pleated structure, here if I am drawing the structure something like this. This is nothing but the alpha helical structure, and if I am drawing in this fashion, that will be called as beta pleated sheet. Okay, this will be the beta pleated sheet. Please do remember one thing, that the first amino acid and the fourth amino acids are going for the hydrogen bond formation, and that is the reason they are having this structure. This structure is also called as secondary structure of the protein. This structure is also called as secondary structure of the protein. So deal with that case as well. Okay. Now, if I am dealing with the alpha helical proteins and the beta helical proteins, do remember one thing, that majority of the proteins found in the animal world are alpha helical configuration, but some of them are having beta configuration as well. For example, wool or silk. These two are the best examples. If you are preparing for the competitive, do remember that the wool and the silk are having beta configuration. The wool and the silk are having beta sheet configuration, or we call it as the beta pleated configuration. Okay. Now, basically if I am dealing with the Ramachandran plot, the Ramachandran plot basically shows that the secondary structure of the protein. Okay, the secondary structure of the protein, and the common example of the secondary structure are none other than the alpha helix and the beta sheet. Okay, deal with. And you can observe that the red color is showing the most allowed region. The red color is showing the most allowed region. Okay, namely the alpha helical and the beta sheet both. Okay, deal with. And if you are dealing with the yellow region, they are having somehow low energy region, or rather they are called as a limited allowed region. They are called as limited allowed region. And the white region, if I am having the white region, they are sterically disallowed for all amino acid. They are sterically disallowed for all amino acid except glycine. Do remember that this is the basic structure of the amino acid. Like I will be giving you one extra hint, that the rotational angle of the amino acid depends wholly and solely on this alkyl group. The rotation of amino acid depends wholly and solely on this alkyl group. Deal with. Whatever, if the alkyl group is only H, that will be a glycine. If it is CH3, that will be alanine. And if it is CH2OH, that will be serine. Okay? Deal with the case. Now, this angle is called as phi and this angle is called as psi. Do remember one thing. And their names are called as NC alpha and CC alpha. NC alpha and CC alpha, the torsion angles. And the torsion angles are having the reach from plus 180 degree to minus 180 degree. Something in this direction, plus 180 to minus 180, and something is this direction, plus 180 to minus 180. This will be called as phi and this will be called as psi. Deal with the case. Hopefully this lecture has been beneficial for you guys. Thank you very much for your so much support. If you are having any kind of doubt, you can ask me there in the comment section as well. Thank you.